Well, hello, everybody. Thank you for attending today's webinar, Delivering Location with the Call Using NENA I3 Architecture. My name is Amy, and I am the Membership Associate here at the National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance the effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more about our organization, please visit us at our website, www.nsgic.org or NSGIC.org. I will also pop that into the address in the chat box. So just some reminders for our call today. All attendees have been muted on entrance. There will be some time at the end of the presentation for Q&A, so please place your questions into the chat box. They will be read aloud at the end of the presentation. And this also will be a recorded presentation and sent out after it comes to its conclusion, so be on the lookout for that. And with that, I'd like to introduce today's presenters, Richard Kelly and Ira Piles. I will now turn it over to the presenters. Thank you both again.
Ira?
Yes, thank you, Amy. I am Ira Piles. I'm with Motorola Solutions, Next Gen Core Services. I am the Location Services Product Manager, and I will be starting this presentation today and then handing over to Mr. Kelly. Let's go ahead and go to the agenda. Richard?
I'll be driving today. Hey, everybody, good seeing you again. All right.
So today's agenda, first we're going to make sure we're all on the same page by looking at some definitions we'll be using throughout the presentation. And then we'll be looking at what we call our legacy selective routing, which is traditionally how 911 calls are routed to the right 911 agency. And then we're going to look at the role of the emergency call routing function within Next Gen Core Services, and also looking at the I3 architecture and the workflow involved in routing 911 calls. And then we're going to move on to a somewhat newer item of OSP, location-based routing. OSP is originating service provider. So in this case, where we talk about wireless carriers. And then we're going to finish up with some GIS rules of the road as we move forward and moving into Next Gen. And then we'll take a look at and try to see if we can answer any questions you have.
To put this into context, I want you all to know, Ms. Richard Kelligan, the point of this presentation is to exhibit the absolutely critical, essential role that GIS data plays in 911. 911 of the future doesn't work without GIS data. It enables and utilizes true GIS, true layer analysis in an automated way in most cases in these systems. So you'll see how we're going to transition from a tabular analog kind of world that we've been used to for decades into this new GIS-based, location-based routing world. And we're going to give you some technical information. It's okay if you don't know it all. You'll be able to have the content of this presentation afterwards for the deck as well, so you can refer back to what we discussed.
Thank you, Richard. So let's get on the same page with some definitions. Tabular routing is somewhat of a traditional legacy terminology. It has no real industry term described anywhere in any official documentation, but those who have been in the business refer to it as tabular routing based on some type of table of information that is used to determine where a 911 call should be routed to. Now, one of those tables that is used is a selective router database. And it is a table of telephone numbers with associated ESN, that's an emergency service number, simply a number, as derived from comparing the telephone records to the MSAG, the Master Street Address Guide. So those first two terms there are related to legacy routing. And we want to let you know where we are today and where we're going to for Next Gen. The next term, geospatial routing, and the way we use that terminology is very specific of how in the Next Gen Core Services, the emergency call routing function uses specifically GIS data to determine the proper route for a 911 call. And then from a Motorola perspective, we rely on location-based routing. So location-based routing kind of expands on away just not from geospatial information, but any type of location information. And it can be in the form of a tabular form. So location-based routing is the use of the caller's location, regardless of how we get that information, to determine the appropriate jurisdiction that a 911 call should be routed to. And if we go to the next slide, we're going to go over some of these tabular forms of data we use today. So the MSAG, Master Street Address Guide database, is simply a table of street names with address ranges low and high, the appropriate community in which that address resides, and parity of the road, even, odd, or even both sides of the road. And there's that ESN, emergency service number. That emergency service number, again, is simply a number, but that number is used to route the 911 call to the appropriate 911 agency. So when a telephone record is compared against the MSAG database, we create what we call an ALI record. So within that ALI record, or the ALI database, is the telephone number associated with the telephone record being loaded into the ALI database with the corresponding address, community, customer name, and there's that ESN, which is obtained from comparing the location of that telephone to the MSAG. So now we have an ALI record, which is used to display at the 911 center when a call is made, the location of the caller. Now from this ALI database, we have the selective router database, another tabular database. And this is the brains of routing in a legacy world. It's simply taking information from the ALI database, the telephone number, and the ESN. And that's all that resides in this database. And this is the database that is used for routing of 911 calls in a legacy selective routing solution. So
for context for later, the ESN from a geographic or GIS perspective, keep in mind that, as Ira said, that's key to getting into the right 911 center, dispatch center, which we call a public safety answering point, PSAP. But it also represents the geographic area of the three main responders: fire, law, and medical. So by extension, just as Ira said, not only do we have a location that's within the ALI database that's now used by a selective router, but by extension, that ESN can also identify the three responders associated with a landline, physical location. So that's really important to know that it sends it to the right PSAP, and it serves double duty as a geographic area, right, a zone. That ESN number reflects those three responders. So it really is an important aspect for everything we use for 911 communications for the last, what, Ira, 40, 50 years?
Exactly. And then the next slide goes into how wireless calls, and it uses the same process for landline calls. And the main point we're trying to make here, whether it be a landline call, your old home phone that's wired to your house, or a wireless call, it all goes through the same process to create data within the selective routing database. Again, simply a telephone number and an emergency service number, as Richard described, identifies who's the appropriate law, medical, fire responders. Now, these telephone numbers in the wireless side are not actually the telephone numbers of the cell phones, but it's what we call pseudo ANIs, pseudo telephone numbers that represent a very specific jurisdiction, ESN, and is simply used for routing of 911 calls. And again, we can see in the selective routing database, we have these individual telephone numbers and an ESN assigned to each one strictly for routing. So if we go to the next slide, we'll see how this fits into the current process. So on the left, we're showing a wireless call with PANI. Again, that's the pseudo ANI. It's not the real phone number of the caller. It is a call. It is a phone number associated specifically with that call, just for the purpose of, well, two purposes. One, for routing the call, and second is for obtaining location information. And we also have a wireline call with ANI, which is a telephone number, automatic number identification. So the calls come into the 911 selective router in a legacy environment with nothing but that telephone number and the voice of the caller. That selective router, what it does is it takes that PANI or the ANI, and it does a lookup in the selective routing database. And as we talked about earlier, that selective routing database has nothing except telephone number and the associated ESN. So the selective router sends the appropriate telephone number to the selective routing database. Selective routing database then returns the ESN, which defines which is the destination PSAP, public safety answering point, that call should be routed to based on the telephone number and ESN combination. It is at that point, once the call is to the PSAP, that ANI or PANI is used to then do a lookup for location information into the ALI database. That query is made to the ALI database, and then location is finally introduced into this entire process after the call is answered at the PSAP.
What's the timing on that, Ira, as far as how fast this whole process would take?
This whole process it can be seconds. It is seconds. It's anywhere from a call setup to 1 to 2, 3 seconds, depending on the phone system, to the call being presented to the call taker in a matter of seconds. Now, how long it takes for the call taker to answer the call, that's up to the operations of the PSAP. And then once the query is made to the ALI database, that's milliseconds typically of how quick the location information is returned. But it's only returned after the call is presented to the PSAP. And that's where location information is brought into this legacy selective routing process. So Richard, if you want to go ahead and cover
Yes.
anything else I missed?
Congratulations. You now know everything that happens in 911 under the hood today. That's what everything for public safety response has been based on for decades. And we're going to change that. Okay, so where do we want to go? The I3, which is the term that NENA uses for their infrastructure and architecture for the next generation of 911. We call it NG911, but there is actually an I3 architecture document. I've talked about it before. The NG911 work group within NSGIC has discussed this as well. It's a standard. It's been built for, I don't know, I wrote what, for 15, 20 years. It's been growing, now a little over 700 pages. It's everything that goes on under the hood, how 911 works in the future. It delivers us an in-state master plan where we need to go. And it's really important to understand that in the future, we have a new acronym. We're going to change from, as he had mentioned a minute ago, the ANI, the ALI, that the context by which the data is delivered in the format, like those tables you saw, we're going to put it into something called a presence information data format location object. Think of it as more of an IP friendly way to deliver more information than the ALI record, the automatic location information. That ALI record was 512 characters. I mean, you could only put the name of the caller, their address, the 3 responders, just other things that could be populated as we discussed in the previous slides. But with PIDF-LO, which is based off of the CLDXF standard from NENA, which itself is a derivative of the federal FGDC location guidance, we have to be able to have even more information that gets down to a much more granular and precise location, which we talked about on other calls, such as the building that you're calling from, what floor in the building, what room. And there's various laws and requirements that are growing that necessitate more granular information. Be that as it may, whether you're calling through wireless or a landline call, which we call wireline, that information will be put into that format theoretically at some point, and that location is going to come into the emerged services routing proxy, which is, think of it as an IP-based selective router, something for the next generation of technology. And you're going to get a lat long, which is going to come in as a geodetic is the term, or you're going to get like a 101 Main Street, which would be a civic location. That information comes into the ESRP, and once the ESRP gets it, it says, you know what, I got to check my map data. I got to check the GIS data. And we have a function. We have could be a server or an application. We have a component, as Ira was talking about, that's going to do the same kind of location lookup. It's called the emergency call routing function, ECRF. And I've talked about in other presentations. It is the brain center for the ESRP, trying to figure out where that location is that's provided by the caller's device and network and provider compared to the map data. The map data will determine which 911 center it goes to, who the fire, law, and medical responders are for that geographic location. It's not unlike doing a quick lookup on your navigation when you're using Google Maps or some other capability while you're driving around. Where am I? What's near you? That's what this is going to be able to do. Once it determines which 911 center based on a polygon layer it needs to go to, it'll push that location recommendation back to the ESRP. The ESRF will say, I know the location. I know which center it should go to. Please send the voice and other associated information to the PSAP. And that's what it does. Remember that the call and the voice does not get to the 911 center unless the ECRF in concert with the ESRP can determine where it needs to go. If it can't, we have a backup called default routing. We don't like that because if we default route to a county and it's the county sheriff's office, instead of maybe it should be going to a police department, there could be a significant time delay, maybe 5 minutes to half an hour, which is important if you're having particularly a medical event or as a raging fire. We don't want to have that happen. The ECRF is important. There's multiple methods to return a recommended PSAP destination. We got this simplified graphic. You're all GIS folks, you know how this works. We got a simplified graphic in the orange with the delineation bisecting this polygon, this parallelogram, two PSAPs, public safety answer point, two dispatch areas. If we have a location that's a civic house type wireline address, pops up here, or you have a cell tower that's receiving a cell phone through a geodetic or lat long, that information will determine which center it goes to in a simplistic way. The thing about the lat long is that we can plot that into a polygon to determine which PSAP it goes into. When it comes up with the civic, the 101 Main Street, we have to have that context within which polygon it is because it doesn't have coordinates natively. So we use road center lines, maybe even address points that are even more precise to figure out which of these two PSAPs that call should go to. So we use that information and then in the ECRF process to figure out where it goes. We also have a tabular database, which can be utilized today for a lot of information. Ira, do you want to speak a little more on what we've got here with regards to the tabular database association with ECRF?
Sure, and the introduction of the tabular database into the ECRF function is the reason we refer to location-based routing instead of just geospatial routing. So what you see on the left side there with the PSAP polygons and the address points and road center lines, that is geospatial routing. It's based on some type of GIS data that a routing decision is being made. But in the case where we cannot use the data in a GIS format to determine where the call should be routed to, we also include tabular data, which may include the MSEG, the Master Street Address Guide, where we can get the civic location information, compare it to the Master Street Address Guide, which still has routing information in it based on the ESN. And from that, we can still determine where that call should be routed to. So in that case, the introduction of tabular data also being included with the GIS location information is why we refer to our solution as location-based routing.
And we're going to get to that in the next slide. We're going to restate the end state slide. Again, what we want to get to, this is utopia. And a lot of folks will be moving towards this now. Many can't for reasons we'll talk about on the next slide. But this is just the repeat of the previous slide, that once that PID flow with all the location components comes in, it's going to go to the ESRP, which is going to look it up in the map data on board with the ECRF, has to be up to date, has to cover its jurisdiction, has to be able to reach out to other ECRFs if a call is outside of its jurisdiction. There's a lot goes on here with this ECRF, but in the end, we want to get that voice and location to the PSAP as expeditiously as possible. I'm going to tell you right now, I'm one of those people where I want my data perfect. No data is perfect. It's never going to be completely up to date because it's always changing in the real world. So there's been a lot of misnomers about how to get the data where it needs to be. Maybe there needs to be a 98% match for the new GIS data compared to the old legacy data. You know, we've been building that legacy tabular data, I wrote for at least 50 years, since the early 70s. It's been used in Most databases, it was built as a customer database for phone records for billing. Originally Ma Bell, and then the breakup to all the other telcos. That database was only kept up to date if you had a telephone you were paying a bill on, and that record was up to date. There's a lot of anomalies within that, everything from temporary holding numbers to test numbers to even numbers that are unlisted address, things that are not allowed to go out. Maybe it's witness protection, maybe it's something that's government sensitive information. So there's a lot of things within the ALI IMSEC which is not going to be directly correlated with GIS data. So this is kind of an art. And what we're here to tell you, when we think about it as location-based routing, we'll go to the next slide, we have to get through a transition process. You can't just throw a switch and say, today I'm using a database I've been building for decades to one I've been building for months, and it's all GIS, because you're not going to have the equivalents, not apples to apples. So we have a new concept where we discuss location-based routing through an augmentation called the location database, the LDB. As we said before, that information, which has been the gold standard for decades, it's working right now. Any one of us call 911, it's still going to be tapped into. That ALI information, everything that Ira was discussing. That location database is now a wrapper. It's a framework by which we can put every kind of database into it. It will help us provide the information necessary to help out the ESRP. So look at this example. On the left, we're back to our PNE and ANI examples. When those numbers come in and we need to look it up, we're going to go to the location database and say, I need a location with that number. And this is after you have your GIS data stood up in the ECRF. So typically, if you look at the incoming information on the left, you see the ESRP in the middle, you see the ECRF on the bottom, PSAP on the right. That's typically considered the next gen as bare elements for end state. But in the transition, we need to have that location database that takes on the ALI and the MSEG information, which may not be as up to date or complete as the GIS data, particularly if you're getting calls from out of area. So we need to have that information available. So as you see, the call comes in from the left, the ESRP, it says, I got a TN. I need to go up and find a location that I can send my ECRF so it can do that lookup for which center to send it to, what 3 responders to send it to. It does that, again, in a blink of an eye, so we can get that voice and location there. Make sense? And I've got your little icon down there. That's you guys. And where we have the states and federal agencies providing ongoing education and guidance on these same concepts, and my counterparts and everybody else in the industry that does this work, we all agree on these same tenets that this is how you need to consider things at a minimum. These are all I3 NENA standards. Ira, any comments you want to have on this one?
Nope, you've got it.
Okay. Let's go to, and again, reminder here, in the end state, we got this shadow version. We all want to not have to deal with the LDB. But I'm going to be honest with you. I've been doing this on the public sector side, outside of government since 2004. Really thought we'd have most of this nailed down with the GIS data. I don't know if this location database, the remnants of the ALI MSAG information, will ever go away. You got to keep in mind that across the continental United States, and this applies to Canada as well, because the NENA standards are meant for North America and can expand beyond that. Even Mexico's looking at what we're doing. That location database may not go away well in our professional career lifespans in the next 10 or 20 years. We don't know. We have some places, Ira, I think you agree, where we barely have enhanced 911. We barely have some of the location information available in some very rural parts where it's difficult to get up-to-date technology and connectivity. But we want to make sure we can keep that around. But when we're ready to do away with it, particularly in larger jurisdictions that have great infrastructure, we do away with it and we go back to the original in-state slide we talked about. Okay.
Richard, can you go back just a second? I'm going to
Yeah, sure.
explain something. Because the way we're showing our slides, and it's for simplicity purposes, we're showing either a slide that has call with a phone number or a call with location. In reality, the system is getting both types of calls, and it's up to the ESRP to determine, is there location with the call? Do I need to go get location? If location comes with the call, then it's automatically going to the ECRF. But it's just hard to show both situations in one slide. So It's not a throw the switch and you're going from only phone numbers to routing to location for routing. It's actually a combination of this slide and the slide before. That's what we call a transition period.
Yeah, and some of you that know me, I can get a little excited about this technology. I have a little bit of a passion to make sure it's understood that GIS data drives everything. Not to mention, because my late mom always asked, why did you get that GSI job anyway? What does that even do? Now I used to explain to her, see, mom, it was important. That's why I went to school for all those years again. So it's important to understand that nothing really happens the way it needs to without good GIS data, and it needs to be maintained. We'll talk about that more. And Ira's going to take you through some of the nuts and bolts of the wireless providers and determining routing. Ira, you want to take this on?
Sure. So now this moves away from what we were talking about before, where we were explaining how next generation core services routes a call once it gets it. This OSP location-based routing, and some of the agencies who might be on this call might be contacted by some of the wireless carriers, or if you read some of the national news articles talking about carriers doing a location-based routing to the proper 911 agency. Well, that's partially true. Actually, what they're doing is using location-based routing to determine which service provider the call should go to. And the picture on the right here is kind of shows current technology, and the one on the left shows current technology. The one on the right shows future technology. And we're going to go into the next slide and get into a little more detail. So in today's routing of 911 calls, you can see two cell phones there. One is in state 1, one is in state 2. So this could be Florida and Georgia or any two adjacent states. And there's a cell tower right on the border. Well, the way routing is done today in a wireless environment is each of these antennas, 1, 2, and 3, are sitting on that tower, and a decision is made ahead of time that if a 911 call is placed from antenna 1, that call will go to state 1. But what happens when someone's in state 2 and they use that same antenna that's already been predetermined that's going to route to state 1? Well, what happens is the call from, if you're calling from state 1, is hitting antenna 1. The cell carrier knows antenna 1 should route the call to call routing provider A, because call routing provider A serves the PSAP in state 1. So that call goes to provider A. They route the call to PSAP in state 1. That PSAP in state 1 determines where they're actually located. And if they happen to be calling from state 2, they have to transfer that call back through their provider, possibly to another provider, to get it to the proper PSAP based on where that cell caller is actually calling from. Now, all of this is because in today's environment, we're routing specifically based on an antenna that wireless phone is connecting to in order to make the 911 call. And it's all based on cell ID and tower information, as I said, which is a predetermined location and routing situation that's built into tables within the wireless carriers' databases.
Yeah, for if you're driving around the countryside, in fact, I just saw this the other day, they put up yet another giant skyscraper tower. For those who always wonder how that stuff works, this is essentially it. A new tower goes up, and Ira, I think you dealt with dealing with this in your jurisdiction, Florida, where you're programmatically trying to figure out how each of the tower sectors should route based on population, the coverage. It's a real geographic process. You have what's called routing tables, I think, that are built for this process. It's usually done in collaboration, Ira, if I'm not mistaken.
That is correct. So adjacent jurisdictions will work with each other for these type of antennas and towers that sit on or close to jurisdictional boundaries. And they'll work together to determine, hey, in this case, it was determined that any calls that hit antenna 1 will route to state 1. And probably any calls that hit antenna 3 will route to state 2. But then they have to really think about, okay, antenna 2, which is right on the border and probably covers both jurisdictions, where should this call route to? So yes, there's a lot of collaboration that has to happen in today's environment to build these tables to determine where calls should be routed to based on each individual antenna.
And I've done this, and just so it's not, doesn't seem like it's way out there. Years ago, we would do routing tables here in Central Texas where we would have maps. If you could get them from your provider with the coverage on these maps, that signal, and there'd be drop shadow with terrain, and you try to guesstimate based on how much population there was in each of the signal areas that were guesstimated, but from engineering, these wireless footprints, which varied time of day, signal strength, orientation. You kind of guesstimate how these get routed. So it really is an art. This has been going on for decades. That's how your wireless calls get to where they need to go, in case you were curious.
Right. And in this next slide, what we're showing is how wireless carriers are moving to location-based routing to help determine which is the proper 911 service provider that the call should go to. And since they're using location-based routing, they're using GIS data, and hopefully that GIS data is the same GIS data or very close to the same GIS data that jurisdictions are using within their own ECRF Next Gen Core Services solution. That is the preference. Hopefully carriers don't go out and get some type of commercially available, that they are working with the local jurisdictions so that the data they're using to help in the proper routing of the call to the right service provider, that data is in sync or even is a replication of the same GIS data that exists in the emergency call routing function in the core services. So in this example here, we're back to the same tower, and we still have the caller who's in state 1. They hit antenna 1, but this time, since the carrier is using location-based routing, they're actually using the location of the phone to determine where the call should be routed to based on where that lat long of that phone falls within the GIS data polygon information. From that information, the carrier will know that that call needs to go, for state 1 call, it needs to go to provider A. Now, the other example, state 2, you have the caller from the cell phone in state 2. And even though in this situation, they're hitting antenna 1, which in the legacy environment would route to state 1, the carrier is using the location of the phone to determine where that call should be routed to, again, based on the GIS polygon information. And that GIS polygon information should tell them that that call needs to go to provider B so that it can be properly routed to PSAP in state 2 and not have to rely on that call going to PSAP in state 1 and being transferred once they discover that this caller is actually in state 2. So the big thing is here, the takeaway is the GIS data. Make local agencies aware that you may be contacted by wireless carriers for GIS data for what they're calling location-based routing. It doesn't replace next generation core services location-based routing, but it enhances the way they determine which service provider the call should be routed to in order for that service provider to get it to the final proper destination PSAP.
So to provide some context here, I ask all of you to keep in mind what we've discussed so far, the role of GIS and map data. Before, it was a nice to have, it was a need to have to augment the caller's voice and directions over the phone in the map display, in the CAD system, computer-aided dispatch systems we've been using for decades. Now the map data is going to have to be understood, built, managed, purchased by local governments for their next generation core services, for that ECRF technology. And we also have to have people understanding GIS technology, at least map areas, right, in a digital format for the wireless industry, for this location-based routing. So you're now having different levels of infrastructure, government and businesses that have to be understanding the principles of GIS data to utilize it. And that's a learning process. It's something important to keep in mind. Ira, will go to the next one here.
Sure, and over these next couple slides here, what we're going to demonstrate is the transition from a very legacy process to a full next gen process. And this slide here, what we're showing is 911 call, cell phone call being made, and the wireless carrier using that, again, that cell ID, that antenna information to determine which router that call should be routed to. At this point in this call, the carrier is simply sending voice and a phone number. Once it gets to the 911 selective router we're showing here in the blue, since location is not provided with the call at this point, this is where we showed in an earlier slide, the routing element will take the phone number, do a lookup in location database, location is returned to the router. Then the router uses that location to determine which PSAP the 911 call should go to. And at that point, in our next gen core services solution, we are sending voice and location to the PSAP destination, which is different from legacy, because in legacy, all you got was voice and a phone number, and then the PSAP did a lookup. With next gen core services, we are sending voice and location to the PSAP with the call.
Another important aspect here, notice we've got, again, our GIS data icon here, that's driving our caller location. Consistency of data between, as you saw with the telcos, hopefully, the telephone companies are using that kind of information from the originating service provider infrastructure point. They're using this, we're using the same one for the ECRF and the NG core services. And hopefully we have similar, if not the same data that's also being delivered to the map displays used in other applications. That's mapped ALI CAD, it could be emergency notification, any number of things, mobile data terminals. So you can see that if we can measure twice, 3 or 4 times and cut once, build the data once to prescribe standards, which is why the NENA standard is important, which we give updates on through our NG91 work group here within NSGIC, as well as the updates I give on behalf of NENA at various venues. It's important to understand what we're all trying to build the data to the same standards by which it's going to be used in all these areas. Anything else in this one, Ira?
No, we're good for this one. So again, the process goes with this time, instead of the wireless carrier using cell ID and the antenna information, it is using actual location of the device to do a lookup in their system, determine which 911 service provider should the call go to. So before it was cell ID or the antenna information, now they're actually using the actual location of the caller to more accurately determine which 911 service provider serves that polygon. So once the carrier has determined which provider the 911 call should go to, at this point, we're still showing that we're receiving voice and a phone number. And we still go through that same process of next gen core services using that phone number to look up a location information, using that location information down to the Motorola decision routing decision box, using the GIS data with the location to determine which PSAP the call should go to. And at this point, the call is routed to the right PSAP with, again, voice and location.
What I would add to that is this is not an easy thing to build out and implement. I know we've got implementations around the country we've been working on learning from to augment and improve this process altogether. You know, you're witnessing, whether you know it or not, you're seeing a revolution, a paradigm change in 911 technology from what we've depended on with copper telephone lines, underground lines, other forms of connectivity in these isolatable 911 centers to an IP-based system, which is really dependent on interoperability, interconnectivity. What was the benefit we said, Ira? The good thing about next gen 911 is everything's connected to everything and everything can be passed between everything. The bad thing about next gen 911 is everything's connected to everything and everything can be passed to everything. Think about those words, because that means for good and bad. We want to be very careful in what we build and how we share, but we know there's very specific steps within the functionality that Ira has just gone through that we have to conform to consistently across the United States.
And in this next slide coming up, now we're getting to the point where we're really reaching the true I3 end state, where the wireless carrier again is using location of the caller to determine which 911 service provider the call should go to. And now what they can start doing, instead of just sending voice and a phone number, they'll send the location with the call. Now, once the router has location with the call, you notice no longer do we have the location database above the router. It has location. It can immediately use that location against the ECRF, comparing it to GIS data, and with that location, determine which is the PSAP that 911 call should be routed to. And again, it's sending voice and location to the PSAP. And one thing I want to make clear, the difference between carrier location-based routing and next-gen core services location-based routing is the carrier simply use location to determine which next-gen core service provider the call should go to. The final decision of which PSAP that call should go to is the next-gen core services responsibility. Because even though the location may indicate that a call should go to a certain PSAP, there's other rules and policies within the next-gen core service routing that could determine a different route than the PSAP that is determined by the GIS data. So I just want to make that clear that yes, we use GIS data to return to the router the recommendation of where which PSAP this 911 call should go to. But there are other functions in the next-gen core service router that it can use rules to determine whether the call should actually go to that PSAP or not. And some of those things are call volume, status of the PSAP. Is the PSAP up? Is the PSAP down? So the reason we don't want to rely totally on the wireless carriers to determine what PSAP the call should go to, because they don't know the status of that PSAP and they don't know any of the policies or rules that PSAP may have in place within the next-gen core services router for that final decision of where that call should be routed to.
The content we provided you is from a two-dimensional perspective. You know, the 3D GIS work group's completed its work. We talked about that several times recently within the NSGIC meetings. And what will that do? How will that add another context to what we're discussing? Disaster management, redundancy and resiliency, whether it's hurricanes in the southeast, whether it's fires out west, flooding in the Midwest, in the Northeast. We've got a lot of other factors that affect different aspects of this. So we have to have backup and redundancy plans for this information. And as I said before, looking at this, the slide before this one, where we had the location database as a transitional element, no data is perfect going in. So everything you see in these colored boxes can go forward with best available data. You may only have an MSAG, and maybe you only have polygons that are suitable for routing wireless calls, for example, with the wireless carrier routing decisions. That can be done with some of the information, as Ira discussed, the ANI, the ALI, the MSAG, which already has the PSAP and responder identifications associated with them. We can carry that forward. That's what the LDB does. That location database can provide access to that good information until local governments are happy enough, or even state operations with their GIS data, that they no longer need that. So it's important to understand transition is going to be going on for a while, different paces at different locations. Okay. Taking us to the end, before we get to the Q&A side, we want to leave you with rules of the road. And before I go through these, Ira, was there anything else you wanted to add on to those diagrams before we leave them?
Nope, I think we've covered everything.
Okay. So keep these in mind. Based on what we talked about, let's bring it full circle to what NSGIC's role is. Having this information available to the state and local governments that they serve, as well as federal agencies that are aware of this. GIS data requires experience and good management practices. Key GIS data types we've mentioned. You're going to have roads and address points, more likely. Polygons above all else. You got to have the outlines for the call centers. A critical polygon layer I've mentioned before are the state boundaries, along with the county boundaries. No gaps and overlaps between them. But if every government's using a different county line source or state line source, that can create problems. So we have to have knowledgeable people and experienced people. Unfortunately, many governments are unable to pay the same kind of wages that private sector has. And we all know and lament this who've been in government. As soon as you get somebody trained up, ready to go, they get another job paying a little bit more doing something else, or their career improves and they do other things. That's the nature of generating really good, talented people from the Iowa side. So retaining those people is important so we can at least keep that data as good or better than what we have today. That's where standards come in. But we have to have good experience and good management practices. So NENA's worked very hard. Stewardship guidance we talked about, that's just about complete. The data model V2, that's about to be released, and others that we talked about in these calls. Reviewing and QC and GIS data, there's not yet a consistent manner by which data should be qualified for specific validation checks. There are some recommendations from NENA, and there are certainly a lot of recommendations in the new stewardship guidance that's about to be released. But by and large, we need to make sure that we find things that are critical issues for the processes we talked about and vet those. And most of the software manufacturers can give you ideas and of where to go for your best bang for your buck. GIS data changes over time. This is very important. Not only do we have to understand that it changes, we need to be able to update these systems, everything you saw with the best, the most current data, but we also have to be able to keep a history behind us. We need to know what was changed and why, particularly if there's some kind of an outcome which requires legal action or some response as to what was changed and when. That's already beginning to happen around the country, usually in light of a disaster or an unforeseen event. We need to bear in mind that there's responsibility for data changes and the history of those changes. Errors in GIS data must be corrected expeditiously. I've had a number of calls from state and local government saying, hey, Richard, is it 3 days? Is it 72 hours? What is it? There's no hard and fast rule about how long you need to, what's the time frame by which you can wait to get something turned around. The rule of thumb is that within 3 working days that a local government or the state has responded to a data error associated with GIS data within about 3 days. So that gives you, if it happened on Friday, you're going to want to get to it Monday. And logging in, Ira and I are working on discrepancy reporting protocols and policies. You're going to want to have that process set up. So error correction on the GIS data, because it's going to affect so many things, very important. And the national standards, as we talked about, I've given presentation on standards updates with NENA, and whatever's going forward, we need to keep up on those. And as I said, as Ira said, as we continue to say, we're in a transition phase. The end state's coming. We know what it looks like, it's standardized. But again, I'm going to say this for the umpteenth time, no database is perfect. We do best available data at the time. As time progresses, things change. As long as we have processes in place at the state and local levels to mitigate issues that come up, we shouldn't have too many problems. And it's, we're changing technologies after many, many decades. With that, Ira, unless you have anything else to add, I'll turn it over to Amy and any questions we may have.
Ready for questions.
All right, well, thank you, Richard and Ira, for that wonderful presentation. We're gonna start with the questions. We got about 10 minutes for Q&A. The first is I believe is a comment from Barry. He says, whether or not the ESN, beyond pointing to a PSAP, also points to a geographic area for a particular response agency is highly dependent upon the complexity of response areas, e.g. a single fire department may have 2 or more distinct response districts. A single ESN cannot point to both geographic areas.
Yeah, and it gets even more complicated with that. Some of those responses, Barry, it's a good point. We're now getting into the things that always gave me a chill in GIS. Donuts, donut holes, overlapping, deliberate overlaps of jurisdictions, a lot of things that are very locale specific. And Ira, you've touched on this coming from your location in Florida. You've had a lot of experience with some of those more recently than I have on some of those things you have to take into account, right?
Yeah, in our jurisdiction, as Barry mentioned, you have a fire department that may respond to 2 different districts, and you do require separate ESNs, and it could be a county police and city fire response, and that's a separate ESN as opposed to a city police and city fire response ESN. So there's a lot of reasons for needing multiple ESNs for a single jurisdiction.
It's kind of like we got the base rules of the road. Now we're getting to the complexities within NENA and a lot of these discussions. What do I do when I have multiple jurisdictions? Next Gen 911 allows us to have multiple responders recommended to the 911 call taker, so he or she can see what the different responders could be. There could be volunteer fire departments, regular fire departments, particularly on a border. Maybe there's an overlap, deliberate or not. There's a lot of things. Then we start talking about federal versus state versus county responders, city responders. There were some examples in the 3D work group where we talked about, okay, I got a call, it's on a bridge. If it's a certain height, it's going to be PD. If it's at water level, it's probably going to be Coast Guard or the sheriff's office with a water response. But how do you know in a 2D world? When are we going to go to 3D and understand that differentiation and understand those responders? The deconfliction of who responds and how will be partly map data related, but also policy. We have policy routing, as Ira said, in the ESRP. It'll say, I know there's 2 responders, but at this time of the day or for this kind of call, I need to send it this way based on policies we have. So it gets a little complicated.
Our next question is from Eugene. What steps can we implement to reach a 98% match rate?
Ira, you want to touch on that for a second?
So NENA has a document which talks about synchronizing ALI, MSAG, and GIS, and that's probably a good place to start. Otherwise, there's a number of vendors out there who are willing to help you move along the way, but I would start with the NENA document, synchronizing GIS, ALI, and MSAG data, because that's where we want to.
Is that 71509 or something like that?
That sounds right. Don't know it off the top of my head. But again, it's attempt to reach that 98% match rate. And the match is you're comparing mostly to your existing location information records, your ALI records and MSAG to your GIS. If you're getting good routing decisions today on your legacy data, you want to make sure your GIS data is in sync with it. So that's the best place to start.
So what I would add to that in some comments, because I've spoken to this many times, that guidance put forward in 2009 by NENA as an informational document. It's not a standard. It's a recommended guidance when we didn't know much. There wasn't a NENA data model. We didn't have the ECRF nailed down. We didn't have a lot of things put in place that we knew what needed to be done. That work didn't really start until 2010. So in 2009, we knew when we went all GIS data, we didn't want to leave good data behind. Bear in mind that most non-wireless calls are going to be in the 80 to 90% range of what's coming in. That document for the ALI MSAG to GIS data reconciliation recommends that 98% match as a goal to attain. It's a recommendation, but it has to be couched with the fact that the expectation is you're making modifications to the ALI and the MSAG data at the same time you're cross-correlating it to the address points and road center lines in the GIS data. That gets lost a lot. It's not just a one-to-one. You're modifying both to bring them up to speed, because you may have good GIS data or bad GIS data, depending on what the ALI and MSAG should be in those traditional databases, whether it's good or bad. Again, we've had 40 or 50 years of building that data, different people. There are 2 different databases built for 2 different purposes that we're trying to cross-correlate. So an important caveat is you're modifying the ALI MSAG at the same time you're modifying your GIS, so they are in sync. That's the whole point of synchronization that gets lost sometimes. And I will leave you the second point on that. If 89% of your calls are going to be geodetic, XY, it doesn't even use the address points or center lines. It only needs the polygons. Polygons are not addressed in that document. So our emphasis has always been, as you saw the discussion with IRA and the OSPs, we have to have the polygons good. No gaps, no overlaps. More emphasis needs to be put on that as a primary goal to achieve before anything else, in my opinion. But we didn't know that in 2009.
So we have a next question is from Clint. What is the difference between location-based routing by the wireless carriers and the ECRF?
This is Clint. You answered my question. I jumped the gun, so maybe move on to the next question.
Yeah, Clint, you didn't jump the gun. I actually saw your question and tried to answer it. So, so thank you. Thank you.
Perfect. Thank you, Clint. Matt, let's see. Matt says, since one person's boundary is also another person's boundary, what roles does mutual agreement plan and PSAP in provisioning polygons in the shared NG911 environment?
Ira, you want to tackle that from the most recent government perspective?
So, I mean, I don't know if you have to have mutual agreements. I mean, in some jurisdictions that's maybe needed, but you definitely have to have a good working relationship with your neighboring jurisdictions. Because the next gen core services and the routing is not going to work if the two jurisdictions don't agree on some type of boundary, because we can't have gaps and overlaps within the boundaries, because the system will not properly route all of those 911 calls. So it's up to the jurisdictions if a mutual agreement is in place or needs to be in place. But if you have a good working relationship, formal mutual agreement may not be required.
And bear in mind that that's a question that's going on across the country. And many jurisdictions are either left up to their own devices, as Ira said, for that relationship, but in some cases, states are taking on the role of trying to help coordinate. I know if you look at, I'm just calling out a few that I'm aware of having worked with. If you look at Virginia, you look at Arkansas, you look at Oklahoma, state of Washington, Kansas, for sure. There are states that have tried to look at a macro level and find a common set of county boundary lines, at least internally, to work from. That's great. I know other states have said, well, we've got so much to work on with the ESINet. You work with the best county lines available. That can generate problems potentially if everybody's using a different set of county lines. I'm using the ESRI set from 2009. I'm using one I got from this company, or I'm using one that's been around our office forever. We really need that consistent set of the common county line files and state line files to use. And that really goes to the coordination across the country.
So it is close to the top of the hour, but I think we can squeeze this last question in. It's from Edie. I was under the impression that ESNs were going to be phased out with Next Gen 911, but you mentioned ESNs are a part of the NG 911. Can you clarify?
Ira, you want to?
Sure. So that kind of goes back to the recommendation, 98% accuracy or a 98% complete synchronization. Use of ESNs in a tabular format is a stopgap. You are not required to be at 98%. While you are transitioning your GIS data to 98% or greater, tabular data, such as using ESNs, can be used for routing within an ECRF. Now, once your GIS data is 100% complete or close enough, then yes, ESNs will be phased out of Next Gen 911. But again, our use of ESNs and tabular data is a stopgap.
So it looks like we are now at the top of the hour. Thank you to Richard and Ira for your presentation today. Any last comments or thoughts?
I would just say thank you to the group for allowing us to present. I appreciate it.
Really do. And if you have any questions, the presentation obviously recorded, and we're glad I've already provided Amy with an output if you want to look at that and go back to your notes. Thank you again for your time, and we wish everybody all the best over the next few days.
Yes, this would just a reminder, this recording will be sent out. So keep a lookout, and Richard did provide me the slide deck, so that will be included in the email as well. But if you have any questions, feel free to reach out. I'm happy to pass this along to Richard and Ira. With that, I'd like to say thank you again to Richard and Ira for your wonderful presentation, and thank you to our entire audience for participating today. Have a great afternoon, everybody.
Thank you.
Thank you.